Einstein's Age of the Universe, from the book, Discovering God in Science.
In 2004, the Hubble Space Telescope took the deepest, longest look into space ever. Astronomers pointed the telescope to a blank area of space, and took a long exposure, which lasted 11 days. The resulting image showed about 10,000 very distant galaxies. Because of the small size, low brightness, and the high redshift of these galaxies, the farthest ones are estimated to be 12 billion light-years away. This means the galaxies are at least 12 billion years old, as the light reaching us has been traveling that long. So if it takes light 12 billion years to travel across the universe, how could God create the universe in just 6 days? The universe expanded at the speed of light. To better understand the age of the universe, we need to understand the effects of relativity on the passage of time. In the 19th century, scientists thought light waves traveled on an invisible ether, much like waves travel on the surface of water. If this were true, then the speed of light would change as we travel through the ether, toward, or away, from a light source. To test the ether theory, two scientists from K School of Applied Science in Cleveland, Ohio, set up a very accurate measurement for the speed of light. As the Earth orbits the Sun during the year, the Earth would most likely move through this ether in different directions, and thus the speed of light would change accordingly. However, after a year's worth of observations, the speed of light remained exactly the same. To explain the Michelson-Morley observations, Albert Einstein wrote a paper he titled Relativity. Surprisingly, Einstein suggested that time is not constant, but can be different to various observers. As the Michelson-Morley observation showed, light always appears to travel at the same speed. Einstein predicted that time will slow down for objects moving at high speed. To help us understand why time slows down, we will construct an imaginary clock, which uses a photon, light beam, as a pendulum. This photon will bounce between two parallel mirrors. In this clock, we will make the photon much larger, and will slow it down considerably, so you can see it move. The time it takes for the light photon to travel from one mirror to the next, we will call a light tick. We will place one of these light clocks on a rocket with an astronaut, who will observe the clock. The clock will be set next to a window so we can watch it as the rocket zooms past us. We have two light clocks here. The one on the left is stationary with us. The right clock will move past us at 34% the speed of light. In both clocks, we observe the photon as it moves. We note that the moving clock appears to run slow. The photon not reaching the second mirror as the stationary clock did. We will now have the rocket pass us at 70% the speed of light, and we notice that the light clock is running even slower. Again, both photons are moving at the speed of light. We will now speed the rocket up to 86% the speed of light, and note that the rocket light clock appears to be running half as fast as our stationary light clock. The rocket further accelerates to 98% the speed of light, and now the moving clock is running only 17% as fast as our clock. The reason this appears to happen is the stationary observer sees the path of the moving clock's photon traveling in a zigzag pattern. The moving clock photon has to travel a further distance for each light tick. The faster the clock moves, the further the photon must travel for each light tick. Since the speed of light never changes, both photons in each clock appear to be traveling at the same speed. Since the photon in the moving clock must travel a greater distance, it takes longer for the photon to reach the next mirror. Meanwhile, the astronaut on the spaceship sees his clock running normally, keeping perfect time. Both observers see the same clock, but see the timing of the events differently. To the astronaut, the clock appears to be running at the correct speed, but to the stationary observer, the moving clock appears to run slow. At this point, some of you might be wondering if any of this is true. Actually, scientists have tested Einstein's theory, and found it to be highly accurate. A practical application are the clocks on satellites, which time our GPS signals. These orbiting clocks run slower, and if not compensated for, your location would be off by several miles. If we could catch up to a light beam, what would happen to time? As you can see, the photon never leaves the surface of the mirror. Why? Because the mirrors are traveling at light speed. For the photon to be able to reach the other mirror, it would have to travel faster than the speed of light. The speed of light is the absolute speed limit in the universe. What does this mean for a light beam? Time has stopped. Time does not exist. Therefore, travel from any point to any other point is instantaneous, no matter what the distance is. Therefore, for a light beam, it is possible to travel all the way across the universe instantly. At the same time, to the stationary observer, it appears that light takes 2 seconds to travel to the moon, 8 minutes from the sun, 100,000 years to travel across our Milky Way, 2 million years from our nearest galaxy, and 8 to 10 billion years from the farthest galaxies. Since the universe is so large, and galaxies are as much as 10 billion light-years away, astronomers say the universe is about 13 billion years old. The Bible says God created the heavens and earth in just 6 days. Because the universe expanded at the speed of light, various observers would see the amount of time differently. God was present at the beginning, and as the universe expanded at the speed of light, he experienced time much slower than we do today. So God could have created the universe in 6 days, and we on Earth can see the universe as being 13.7 billion years old at the same time, because we see time differently. So, from Einstein's proven theory of relativity, both answers appear to be correct. The Bible and science, both at the same time, but from different observers.
The age of the universe question is the number one reason young people stop attending church. This ends the presentation. Thank you for watching.